Hi everyone, welcome to this chapter 2 of construction innovation. So here we're going to get our teeth a little bit more into the theory of things, and we're going to look specifically into incentives for innovation in construction. So as an introduction, what is wrong with the construction industry? Why does everyone have this perception that it's behind on innovation? So we're going to look at that. Then we're going to look at the global economy has continued to grow because of ongoing and innovation-based competition, national and regional economies, as well as the industry sectors and industries are being transformed through innovation. So we're going to look at that. In this chapter, innovation causes problems between aggregate and individual people and organizations. Value creation is smaller in the construction industry than in other industries. So we're going to look at these types of items. Then we're going to look at innovation as a lottery. We're going to compare it to a lottery. You can either see it as a lottery, either it's you're going to innovate and it's going to get some money off, you're going to make money off of it, or you're going to just spend a lot of time and money in it without really getting anything back. But that's a very cynical way of looking at it. But investing in construction innovation is different than, for instance, the pharmaceutical industry, where things can be used over and over and mass produced. Any mass production innovation there makes a big difference and gives you a large competitive edge. Whereas winners can make fortunes just as losers lose substantially. However, as history has shown, innovation pays off in the long run, and that's very important to keep in mind, the long run of anything. For instance, any investment it takes up time and so on, so you must be willing to stick with it. Okay, there is no immediate correspondence between the growth of the economy as a whole or the industry and the economic development as a single firm. That is very important. You might think that a single firm and the economic growth usually grows hand in hand. Obviously it does, but a single firm's innovation has some spin-offs of it or some advantages to it, but you can't for instance grow as a company and now suddenly whenever you start doing your finishes on a building, for instance, and the rest of the industry is lagging behind on it. So or for instance, you can do a nice innovative design on a new building, but then when it comes to the finishes, the whole project kind of falls flat because the client didn't have enough money to actually finish off the build as he should have. So you have speculative investments in innovation, and that should be avoided, and rather to invest in scarce resources. This is very important. Innovation these days is actually just having the right personnel, using the existing innovations that we've got available optimally within any industry. We are project driven, trying to make as much money as possible on a single project, so that's very important to keep that in the back of your minds as well. There are economic incentives and non-economic incentives, such as value orientation, social relationships, norms, formal laws, and other regulations. You can think of social relationships, for instance, if you build a good relationship with a client, you're more inclined to get a new appointment from that client. So being innovative in that manner, for instance, having your presentations correct and presenting it very well to your client may have a big influence on the next job that you have to do. Okay, so the next thing that we're going to look at is construction innovation. And construction innovation differs from production of goods As already explained, car manufacturing and construction manufacturing differs quite a lot. Although there is a few companies in South Africa already testing the waters with container constructions. Although I did a calculation the other day, most of your finishes still contribute to a large amount of cost, so it's not really that cost effective. It is quite cost effective if you want to have a small build, but as soon as you get to a larger build, it doesn't really make monetary sense to go that route. So, but still you can evaluate items like that. Innovation is a novel combination presenting a break with the past. It is not profitable on the onset. Obviously, you need some capital to do it. It becomes profitable if successfully introduced and assimilated in a gradual transforming economic system. So you have to have a buy-in from the clientele, for instance, and basically it just has to work. You have to become very efficient with your innovation that you're implementing. It is not exact and a rational calculation, very important, because you're a trendsetter if you do implement items like that. It is driven by passionate human beings, usually someone that wants to prove a point. And then a novel combination of innovation are normally made from resources that have already been exploited in the existing systems. It causes disruptions. Okay, that's something which is always a big thing whenever trying to do something innovative, is someone will always tell you it can't be done like this, or because everyone is normally set in their ways and have is very conservative. The construction industry is very conservative in it, because any mistake that you make in your implementation has a big spin-off on it. If you make a design mistake, it causes a lot of additional costs, and you're liable for quite a lot of things if you make a mistake. Okay, capitalist dynamics are not simply marked by creativity and growth, but also by the disruption and destruction. So the main thing is, with this new innovation, obviously you're going to take work, if it's successful, you're going to take work away from other places, and obviously you're going to create new opportunities, but you're going to make some other people lose their jobs also as well. Okay, value refers to the generic utility that is potentially beneficial. Okay, so we're going to look at value quite a lot, rather than the potential money factor. Okay, and that is what you're aiming towards whenever using using innovation. Really, is the value that you can get out of that. Okay, so we're going to look at a few things here. Here, value refers to profit, but to generic utility of what is created, that is potentially and directly or indirectly by entering into other combinations, serves to satisfy the human needs. So for instance, you might have a new lightweight steel construction, but it will detract in certain aspects from your client's value. But with the lightweight steel, you can maybe create new designs or structures which actually will create more value for the client. So if you're going into that direction, something that you need to focus on is more about the value, the design, maybe a cost saving, less hassle, quicker site performance, so the client isn't involved in a elongated construction period where things aren't really going their way and they have to break down a wall or anything like that. Whereas, for instance, lightweight steel construction will iron out those items whenever it gets into the build. So it's just an easier build, but it doesn't necessarily give the client the same product as it would have been in the past. Okay, so value is not equal to profit, and that's something that's very important that we need to remember. Value as a collective is to the value or the benefit of everyone. So for instance, the builder might lose some of his profit because he's not going to be on site, he's not going to buy the brick and mortar, for instance, so he can't put a markup on that. But then again, the whole build experience might be more enjoyable by or enjoyed by the client and other people on the site, for instance. So this is just using an example of how the community actually benefits from everything. Okay, some additional information that you can look at. Innovation is in the center of what is desirable for the users, what is viable in the marketplace, and what is possible with the technology available. Okay, so this is where you want to get to, is whenever you're trying to innovate, you need to look at what's the desires, what is available or viable, and what is possible with the current technology. So innovation in construction. Construction produces a unique product each time, and that is the big challenge why innovation isn't that easily used or implemented in construction. For instance, like car production, where each new innovation can be utilized on each new build and it can be mass produced and so forth. Routine-based production and mass production has the advantage of task specialization, repetition, learning, e.g. car manufacturing, like I just said. Construction resembles development phase, the development phase of the above, but then modularization, standardized design, specifications, and routine institutionalized items are efforts to make the complexity manageable. Okay, so very important. These things are already happening or has already happened to a certain extent. So we've got modularization, standard designs, and specifications that's already helping the process along. A simple thing, for example, the 6 stages of construction that we're already aware of, makes the design process so much easier for whenever you're getting into a design, for instance, and you say, okay, we're at level 3 or stage 3 of the design, then everyone on the project team already has an idea. Okay, so the concept drawings have been done, the layout is more or less finalized, and okay, so we can maybe start looking at the elemental estimate, for instance. Those are all standardized items that already kicked in a couple of years ago. Temporary nature of construction doesn't assist, like I said there at the top. And although construction may look like innovating, in reality it's not. In the sense of, if you compare it to other production lines, it is still, each project starts from anew. So you start with a design each time with phase 1 up to phase 6, whereas a specific car still goes through all those different stages as well, from the design, the concept, the design, and so forth. But the next design is the same team using the technology on the same item, but the difference is you're still producing a car within certain limitations. It can only fit onto a road which is 3 meters wide, and the tire size, the wheel size, those type of items all stays the same. So you can maybe have a small change in the electronics, but then that change can be used on a new car as well. So that is the innovations that can be transferred. Whereas in construction, you have a whole new design. Each terrain differs, the suppliers in a certain area all differs. So those are the complexities of construction, which is difficult to take up new innovations. Okay, then the complexities, okay, I've spoken about that already, so I'm just going to run through these. Couplings between firms in the construction industry are generally loose, so you have you have different components in the design team, and then you've got the contractor on the other side, and so forth. So there's a whole complex relationship between them. Okay, then we've got subcontractors and temporary workers. Safety is also an example in work, and managing this with many layers of subcontracting. It's in an open environment, it's not in a controlled environment. Realizing the full potential of a human being's depends on the individual's ability to let go of controlling particular aspects of performance. And then, as can be seen by observing construction project communication, some knowledge is shared, but in general information is very unevenly distributed between people. A simple thing like the drawing and delivery to site. Electronic monitoring of the drawings that's been issued does help, but it's still a thing that's not really optimized yet. For instance, if you've got a new set of drawings that's being issued, do you take the old drawings off of the site, or is it replaced? Is the drawing register there? What type of system is in place on site to actually take up new information and so on? So each site differs in this aspect. Then you've got specific actions often can be fully known only by the workers themselves. For instance, someone that lays the tiles has the hands-on experience, but someone maybe doing the design or issuing the instructions of what work has to be done during that day doesn't necessarily have all of that information. With decision-making situations being complex, so much critical business knowledge being tacit, no single person will be in a position to base a decision on all of the information. For instance, again to the tilers, going to the tilers, if you're a tiler and you're specifying a special and the architect specifies a specific tile, it's more about aesthetics. It's not really about the workability. For instance, if you're working with a 900 by 900 millimeter tile in comparison with a 300 by 300 millimeter tile, the grout spacing, that type of thing, all has impact on how that item is actually done. So you don't generally find a design team sitting down with the tiler whenever they're doing a design. So there's a lot of information that's not actually getting to the designers from that point. So that is the complexities of the construction process and projects. Okay, again, and you always get this thing of I can get it cheaper somewhere else. So clients and my contractors, people that procure, doesn't necessarily always consider the practicality and the experience of the suppliers or installers and so on. So that's another dynamic that one also has to think of. And apples are not always compared to apples in the merit of higher quality, and quality isn't really understood. So these are the complexities that has to be considered whenever working on a project. Okay, then we get to a specific term, multi-parametric optimization. Okay, so it's big words, but we're going to look at Pareto optimality. This is basically where, sorry, where you have a optimal design where the designer actually has a lot of insight into how things work, and where a team has worked together on multiple projects and they starting to work and gel together. The construction industry consists out of multiple systems with constraints that are dependent on each other. Okay, so we've established that. The accuracy of one system cannot ignore the other system. Okay, so the one system is reliant on the other system. New curved windows, for instance. Can you buy it in South Africa? Not. We had a project the other, now almost 3 years ago, where the client wanted curved windows, and then just a year before, the plant that actually produced curved windows in South Africa closed down. So those windows wasn't available anymore. So we had to revert back to smaller glazing sizes with butt joints in between to make up for that, or otherwise we had to go overseas to actually get those glass or those window panes manufactured there. So those are the things that you encounter on a project. Another thing that happens quite a lot is you get imported tiles, for instance. Then a year after the construction or the project has been finished, now a tile has to be replaced. There's no attic stock anymore. Now those tiles has to be imported, or you can't get a nice sample of that. Then you have to get a local tile which is similar to it, and you don't get an exact match to it. So those are the things that you need to consider. In B, okay, so balance is needed. Sorry, almost skipped this point. Balance is needed, and the Pareto optimality is reached here. So this is a fancy Italian word, basically saying where you have a design team in sync with the manufacturer, the contractor, and everyone, and we have an optimal design and build experience in a construction project. Okay, then in B, no single improvement can be made to any element in the system that would create a net gain for the system as a whole. Okay, so you might have one small innovation, but it won't necessarily have a big impact on the whole project. You might have something like a solar installation. It will assist in the electrical aspects of the project, but it will not necessarily address all of the heating requirements, for instance. Okay. So this is hampered with complex systems such as construction, actually implementing new designs, new technologies, and so on. Is there someone that can actually fit these items very well without hampering the aesthetics of the project? There are multiple stakeholders, and the project is limited to what single stakeholders can achieve. Okay, so for instance, you've got stakeholders that wants to provide low-cost housing with their own solar geysers and so on, but then you need to think of the actually beneficiary, where solar geysers might have a little bit more maintenance towards it, so the stakeholders of the actual occupants will have to be a little bit more involved in that aspect, for instance. Okay, so in conclusion, complexities create uncertainties and make stakeholders more prone to stick with the established methods and solutions in their work than they would have been in the level complexity if the level of complexity were lower. The common thread running through the entire discussion in this chapter is information. What information can be conveyed to whom, and who can actually implement that? So the main thing is, whenever getting to innovation, it should not be over the top. It should someone should be able to produce it and deliver on it. So those are the two contrasts of it. Okay. Thanks everyone. That's chapter 2 of construction innovation. We'll see each other again.